Okay, so basically we have gone through how we apply these productivity maps. First, evaluating the variability, characterizing that based on the soil sample or based just on physical aspects, and then making management decisions in order to save inputs. A very simple general rule. And now we're going to go to more specific cases by Francis, who will show some of his experiences using these productivity maps to make good management decisions. So I will going to change the screen. Francis, do you hear me?
I hear you, Ed.
Oh, great, great. Well, thank you, Francis, for taking the time, and we look forward to your examples.
Okay,
So it
got
should
you. You got me
go.
there?
It's coming up. Yep, we can see that. We can see your screen.
Okay. Okay, what we've done, this is a farm, and I'm going to break it down into 3 sections. As it has shown you from the NDVI has converted to productivity maps, the next tool from productivity map is to get into what we would call the sampling polygons, because we are doing variable rate fertilizers, what we want to do on this farm, and we break these up into your productivity zones of low, medium, and high in this case. And each one of those is a sampling zone with a number 52, 53, 54, and 55. On this, from here, we then set up a soil sampling within those zones and make composite samples from each of these areas and put those into one packet. I don't want too many zones if I can help it. So in this case, I've broken it down into 4. This farm has also got a pivot on it. So once we get the soil samples, I'm going to show you the pivot. Now we've got the pivot area in here, and you can see on the bottom left-hand, bottom right-hand corner an area of low production. On the top right, you'll see an area of low production. The rest is medium to high production. From these soil samples that we've collected, we've then done, and I'm using an example of one of the other farms. So let me just get that out of the way. Using a typical soil sample would have come through from the laboratory, and anything highlighted in blue is an area of concern, either deficient or low. Areas highlighted in red are excessive and create their own set of problems. We're going to go down to the bottom. Those areas highlighted in red were zinc, manganese, iron, and sulfur. And if we look at the expected deficiencies, and this is what we call forecasting macro and micro element deficiencies, I'm trying to look at the chemical component, not the physical or management component of what the imagery telling us. This in this says zinc is high and can induce a phosphate, iron, manganese, and copper deficiency. By the same token, excess manganese will give another phosphate deficiency, calcium, iron, zinc, and molybdenum. And we can go through each of those areas that was highlighted from the soil samplers on a default setting. Then from there, I'm going to show you, we do, let me take a lot of these things out so we can have a look at it now. And what we've got in this area is you can see an area, a sample zone 52 required 3 tons of calcitic lime in this case and 200 kgs of potassium sulfate in this case. 53 needed 1.75 tons versus the 3 from the previous area. So you can see this area is highly acidic, and there's a pH issue that was causing the main problem. There was less need for both correcting pH or potassium. The bottom here, 54, needed 3.5 tons of lime. It was actually even more acidic, but it needed a bit more potassium. There were other limiting factors that were corrected in the fertilizer program. But the area 55 had needed 2.5 tons of lime, 100 kgs of potassium, but it needed 10 kgs of a polymer because the main problem on this bottom right-hand corner was salinity. We can go back now to the leaf samples that we then request be followed up during the season. I said this is an example. So we have the soil sample on top, and the line recommendation for the farmer, but on the bottom one is the leaf sample, at the top row being the crop norms, red being excessive and blue being deficient. Recently, we've introduced a diagnostic indices system, which is then, it's instead of using the crop norm methodology, it is measuring nitrogen against all other elements measured. It then does the same thing for phosphate, potassium, calcium, and magnesium. And from the combination of these two, soil and leaf sample, we're able to determine there's the line program, fertilizer program for planting or top dressing, and then extra, in this case, extra nitrogen with an accumulative fertilizer yield at the bottom. So that is how it's normally presented to the farmer or his advisor. To illustrate the effect of where we've done a correction, on the left is maize that's had the full correction with all the correct phosphates, sulfurs, zincs, molybdenum, and boron. On the right, received the exact same amount of nitrogen, phosphate, and potassium, but you'll notice by missing out on the key elements that were deficient, you'll see a variable difference in the crop, the flowering date, the height, and the yield difference in this case is what we really want to focus on, and Ed alluded to it. On the left-hand side, there was an extra 6,000 Rand cost for 15 hectares in fertilizer. The bottom, they didn't put that 6,000 in, yet the yield difference loss will be somewhere in the region of 300 to 320,000 Rand this season. And this is really the tool we are using on the nutrition side. We then still have to ground truth the areas for drainage, wind, rockiness, soil type. But in this case, it's an example of, by using the correct, identifying the zones, sampling them correctly, analyzing it correctly, making the correct recommendations, and variable rate application, what the difference would be between a treated versus, or a corrected versus an uncorrected zone. Okay, any questions from the field? You know, I'm just saying this is an extremely valuable tool as a management tool, and this is illustrating, put it together, this is the result we get.
Great. Great. Yeah, we see this this same cycle over and over again, and it's very interesting to go through it. And Francis, so in some cases you have taken decisions to address salinity. In some cases it was a nutrient deficiency. Is that
Absolutely.
a fair statement? Mm-hmm.
And yeah, and so that would bring me on. And Ed, I don't know whether we do it today or do we do it on the next session, where how we determine how to treat salinity. We can do it today, or we could make it with a real case study for next session, which I suspect is the better way to go with that.
Yeah, I think that would be very interesting. We can accommodate another session for that purpose, just to analyze how we deal with salinity. I think that would be very efficient, because it's an issue that we see in many different regions. So yeah, next session will be focused on yield maps, all the information that we can collect from yield maps, and we can accommodate the fourth session on dealing with salinity using, of course, technology and agronomic criteria.
Correct. I don't know if there are any questions from the floor, Ed.
Yeah, I'm checking on that. No questions yet. Are we coming out fine? Any comments from the attendees? No, not so far. So I will just go into the conclusions.
Okay, great. Thanks, Ed.
Okay. Well, thank you very much, Francis. Thank you very much. It was very, very informative.